This is the video for Unit 7, Lesson 7, exponential, solving exponential equations using the base change formula. So the goal is going to be similar to the last section. The only thing is for if you don't have a calculator that can evaluate logs that aren't base E or base 10, you might need to use the base change formula. So the steps are going to look very similar to what we already saw. We're going to isolate the base, take the log of base b of each side, but use the base change formula as needed, and then solve for x. So if you remember, a few sections ago, we saw that our calculator, some calculators can't do logs that are not base e or base 10. And so when that happens, we have to, do a workaround and use our log properties where we have to use our base change formula. So that's the log of m over the log of b. So in these examples, you might find that if your calculator can't do these type of logs, without this formula, you might have to do like an extra step, but the concept is very similar. So for example, with number 1, we're solving for x. I isolated my base of 2 on a side by itself already, and we're going to do log base 2 of each side. So nothing really too different so far. We would get log of base 2 of 61. What we're going to find, though, is our calculator cannot do, some calculators cannot do log base 2 with that, so we have to use our base change formula. So when we go ahead and solve this in our calculator, and I'm going to pull the calculator up here, we have to do log of 61 divided by the log of 2. So that's like in our base change formula. So the log of the value over the log of the base. And that's the same as log base 2 of 61. So if I was to hit enter, that would actually be my answer, 5.93, right? So in our calculator, we have to use our base change formula, or change of base. So again, it would be the log of 61 over log of 2. Same thing for the next one. I'm going to go ahead and isolate like we did before. We're then going to take, in this case, log base 4 of each side. So we get here x equals log base of 4 base 4 of 30. And again, we have to use our base change formula. So on my calculator, I have to actually type in log of 30 over log of 4. And then you would get 2.45. And again, if you want to write it out, you're welcome to. So some students like to write out the base change, or you can just put it right in your calculator. But we have to use that property if your calculator can't do those bases. For the next one, same thing. You would go ahead and solve. So I'm going to get my base by itself. And then I'm going to do log base 3 of each side. Again, my calculator, the one I'm using can't evaluate log base 3. So in your calculator, you just use the base change. So you would say the log of 19 divided by the log of 3. And then it would be 2.68. And that would be it. So the solving is very similar to what we saw. It's just an extra step you need to do. For the next example here, same thing. We just might have to do a couple other steps. So if I isolate my base of 2, which is already isolated, I'm going to do log base 2 of each side. So x plus 1 equals log base 2 of 50, which again is just a number. So I'm going to leave it in that form just for right now, and then solve for x. So log base 2 of 50 minus 1. And then I could actually put all of that into my calculator. So I have to use the base change formula. So log of 50 divided by log of 2. I'm going to hit enter, but you could actually put it as one whole thing. And then I'm going to go ahead and subtract 1, and it'd be 4.64 if I did nearest hundredth. And that would be our final answer. The next two are the same thing, so I'm going to get my base by itself. 4 to the y plus 3 is equal to 28. And then we do log base 4 of each side. Y plus 3 is equal to log base 4 of 28. Log base 4 of 20 is just the number, and then we're going to subtract 3 from each side. Again, we have to use our base change formula here, so if I pull up the calculator, same thing, so I have to type in the log of 28 over the log of 4, and I get what that value is, so 2.41, then I'm going to subtract 3, and we're going to get negative 0.596. So if I round to the nearest hundredth, it would be negative 0.60. For the last example, this is the final one, same thing. I'm going to get my base by itself. Take log base 3 of each side. So we get 4x equals log base 3 of 45. And then we're going to go ahead and divide by 4. Since we have to use our base change, I'm going to, again, just do it in the calculator. So the log of 45 over the log of 3 would give us 3.46497. And then I'm dividing it by 4. And you would get 0.866 or 0.87. If you have any questions, you can ask during class, sign up for T-Bolt time, or go to the center.